Hello everyone, good evening. Hi Dinesh, good evening. Hi Venkatasai. Is, is audio and everything okay? Great. So we can start probably like after 2 or 3 minutes. Okay, so like yesterday's session and then you were able to uh, like do what we did yesterday, like clone the repositories and like all those stuff or like any issues there, anything that we need to sort it out. Hi Siddharth, good evening. You can call me Siddharth. So yeah. So today's session will be uh, doing everything in like hands-on. So it's like we could just like get started with our like coding stuff. Like we would just like set up the base code for our front end and back end. So that kind of would be the agenda for today. Okay, spelling is very, you can just call me Sid, so that's okay. Okay, I think we can get started. Right. So yesterday we kind of like just did a recap on the use case. So the recap on like again the study pal app that we are trying to build and like what are all the specifications and how we are going to build that and all those of stuff. Right. And the main thing that we did yesterday was to set up the repositories for the front end and back end and trying to see like how you can uh, you know clone the repositories or we can fork the repositories like basically like how to work with that. So that was the main thing that we did, and I hope you were able to do those things like replicate all those things. And also today I've made a video specifically for this purpose so that it's again it's just for that purpose of like how to clone the repository, how to fork, how to update, and how to update your repository with the upstream repository and so on. So like if you are facing some issues, if you are still doubtful about few of those things, you can again watch that video, so that would give you like a better understanding. And today, let's again get started with this, and this will be the agenda as I said. So we are going to discuss about two main things, not discuss, but kind of write some code, build the base code for our entire application. So we have been discussing that we will make sure that we decouple the front end and back end. So some of you might not be familiar with this terms, like most of you might know this, but for those who are not aware about this is right. So front end is something, let's say what a user would face, where let's say a website or somewhere where the user can type in something, they basically interact with the application. And backend is the one that does this processing. In our case, it's going to process the data, process the question that the user asks, and process the documents that they are going to upload and connect with the LLM. So all those are going to be handled by the backend. So the front end would be connected with the backend using APIs and endpoints. So for this API backend, we will be using Fast API, and for front end, we'll be using Streamlit. And for backend, right, we have several options in Python. So we have something called as Django, which is kind of a full stack tool. So there, like you can build full fledged application and so on, but the learning curve is like kind of steep. It's kind of a bit complex for our task, right? Because our part of our process is to write APIs, but we shouldn't spend a lot of time on figuring out how to write these APIs. This is kind of a bit simple when it comes to Flask and Fast API. And uh, the reason we are going with Fast API is like, again, it's kind of slightly faster with Flask, and it's like I would prefer using Fast API, and there's like, there's no strict rule on you have to use Flask or Fast API. Again, it's all about a preference, and the one advantage with Fast API is that it comes with that automatic docs documentation that it provides with Swagger, where you can just like go to the localhost URLs and do a slash docs, and you can see like what's the input you have to give, what's the output, and all those things. So you can see that. And again, the other thing is like the fast API being faster compared to Flask. So those are like the main advantages. And for application, again, we will be using Streamlit, but this is like one main aspect of our application that we are thinking about, that we have to make sure that we build something that's easily kind of, we can switch from Streamlit to a different proper user interface. So Streamlit is again a great tool for Python programmers to kind of build something, build a user interface, build a screen completely in Python. So that's a great thing. So we don't have to learn the UI tools and UI programming separately. So it kind of like helps a great way in that. But the thing is, it's not that great when you're going for a production level application, because there are a lot of restrictions on how your user interface looks like and so on. So actual product, we usually like go with a different user interface. And when you're working in a company, like they're using like different tools, Node.js and Angular or something like that. And even the user interface, it can be used in mobiles, and they can also develop user interface for mobile separately. So we shouldn't have this entire code in the single place, the Streamlit, and we are calling the LLMs and all those stuff, because now you have to refactor this everything when the Streamlit changes. So that's why we are separating clearly this backend that we are going to build with APIs and fast APIs, and the front end that's going to handle the Streamlit. So that's why we have like two repositories as well. So this is what we would get started with. So we won't go like into like complex coding part and all this stuff, but we will just like get started with building the base, the skeleton for our APIs, and we would try to again build a Streamlit user interface. And then we would call this fast API endpoint from Streamlit and see like how everything kinds of like sticks together, how it's kind of like stitches together, so it's to see like how this integration happens. And then we can add feature by feature, add like more things to the front end and the back end as we move on. So this would be the agenda for today's video. And yeah, we can get started with the actual coding part. And before that, if you have any questions in the meantime, you can put it in the chat as like I open my PyCharm. Okay. So this is our backend code, and this is our front end, not the code, the repositories. And we have already connected with PyCharm, and that's what we were like discussing yesterday. So first, like we can just like build the backend, and then we can kind of like go with the front end, the Streamlit part. Sai Nikhil, what other alternatives we have for Fast API? So we have Flask, which is like similar to Fast API, and the other thing is like Django, which is a bit complex. Like for again for beginners, it like you have to learn Django separately, I would say. Fast API, like building these APIs are like much simpler. So like the alternatives, if you ask me, like I would say you to try Flask. Again, Django if you want like a full-fledged thing, but it would be a bit heavy, as it's more of like it can do other stuff apart from, it's kind of like a complete web framework, right? So that's about it. So yeah, you can definitely try Flask. So here we open this backend part. So first thing, I'm going to install some libraries. So we already have this requirements.txt where we have tried to, mention fast API, and we have seen how we can install this library. You can just do a pip install our requirements.txt, but we need like other libraries as well. So here I'm going to install a library called as python-env, pypa. I'll explain you like the purpose of this libraries as we work on this. So I'll say we need python.env. You can see those green lines. That means those are the lines that we have added. If you modify a line, right, so that would look like green in color. So that's again coming from Git. So you can see like we are working on the dev branch as we have discussed yesterday. So yeah, so we have fast AP, and then we would need let's say UVCon. So in order to find the latest version, you can just like go to Google and search for say UVCon PyPI. So UVCon is like the server that has like basically on your server your code runs, and the UVCon is the server in which we are running it. And FastAPI is basically the tool that we use in order to write this API scripts and all those stuff. And the other library that we are going to use here is Pydantic. So Pydantic is kind of a interesting and kind of a useful tool that helps us to validate the parameters. So let's say that you are writing a function that takes a question as input, and the question it should be in a string format. We can add this Pydantic in order to validate that the input is getting sent in a proper way. So for that data type validation, Pydantic is useful a lot. And we also have like Pydantic as came up with Pydantic agents library, so which is again used to build generative AI agents. So it's good as well. So yeah. So these are the four things that we need. So we have this in our root directory. So you can open your terminal and you can install it. As you can see, my virtual environment is already activated. In order to activate this, you just need to type in, right? If it's not activated, you wouldn't see this. To activate this, you just need to say v/scripts/activate. So all these things we have discussed in the yesterday's stream. So you can just refer to this, like if you are not sure like how to create this virtual environment. So here I'm going to install this library by saying pip install -r requirements.txt. So this is going to install, like we have already installed fast API, so it's going to say requirement satisfied, and then it would install like python.env fast API UVCon and pydantic. So python.env is kind of used to load the environment variables. So here we would have like a lot of secrets and keys that something is going to take. Like say for example, if you're using Grok API, so we need the Grok API key and we need to save it somewhere safe. You shouldn't put that explicitly on your code. So what we would do is create a file called as .env, and then we would put our API key there so that it's secure, and we don't push that .env to GitHub because others could see it. So for that purpose, we use this python.env to save that API keys and some secret information in that .env file. So that's the purpose of this particular library. So these are like the first four libraries that we'll be using. And the next thing that we can do is just like get started with them with some like basic Python code to write this fast API. Like we are just going to build a a API that just takes a question as input and just like send a hard coded answer as output. Later we would replace this with the output from the LLM, but for now we can just like send some random answer. So that is the thing. So I'll close this and I'm going to add another file. So I'll right click here and say new and click on this Python file, and here I'm going to say main.py file. So it asks like, do you want to add the following file to Git? I can say add. So now when I can just like right click here and I can just go to Git and I can just like commit file. So now it would like push the file to the GitHub repository. Or you can also do this from the terminal. So once you add it, you would see that in green in color. If you say no, I can add it manually later. So it would be like kind of orange in color. That means it is not added to Git yet. So that is about it. So now let's say from fast API, import fast API with the uppercase F and API. And then we can say from fast API dot middleware dot course import course middleware, and then import UVCon, which is the server in which we are going to run this, and then say pydantic import base model. Okay. So now I'm going to say app is equal to fast API. So we are creating an instance of this fast API and saving this in our variable called as app. So this is what we are going to use later in order to start our API application, API backend. And then I can say course settings. I'll explain you what is meant by this course middleware and this like course settings. We can say origins is equal to put asterisk over here. And what this is going to do is allow all origins, and it can be modified to restrict access. Okay, so now we can say app.add middleware, and then we are going to pass our course middleware that we have imported and say allow origins is equal to origins. Next is allow credentials is equal to allow methods. So this should be asterisk again. Allow headers is equal to asterisk again. So these are the things that we need. So let's try to understand, like, what are the stuff that we have here. Uh, so this CORS, CORS, right? So this CORS basically stands for Cross Origin Resource Sharing. What it means is you have a front end and back end. Let's say that your front end is running on a domain, something called as studypal.com. And your backend is running on a different server on a different domain, something called as XYZ EdTech company. So these two are running on different websites, different sites, and what we call as different domains. And our browser doesn't allow the front end to access this backend as these two are from different origins. When I say origin, it's like basically the sites or the domains where they are running. In order to handle that, what we would do is say that let's say the front end is running on studypal.com and the backend, this API is running on this xyztech.com. So we add this front end domain name here. So I would say that studypal.com. So that means it's telling the browser that I know it's coming from a different domain, but I want you to allow it. I mean, it's a trusted source. You can allow to access the backend. So that's the purpose of adding this, you know, cross origin resource sharing, where you're allowing this cross origins means like the two different domains that you have. So you're allowing to, share the resources. So that's what this is. When you put an asterisk, it's like saying like allow all origins. I don't mind if it comes from any domains, so that like it can be accessed by anyone, like building like APIs on, sorry, the front end on any tools and from any domains. But if let's say we are building this for our sake and for internal purposes, we would just, let's say, put it in our company's domain. So your front end would be in the company's domain and the back end would be in the company's domain. In that case, you don't need course because both are from the same thing. But even if it's in different domain, we would just like mention like all the domains it can access. So let's say that it can, the front end can be built on 5 different domains. We list all the 5 different domains. So think about this as we build a backend and 5 different companies, 5 different institutions are going to build their own user interface, own front end to access this backend. So here we would add like all those domains here. So that's the purpose of having this origins. And then just like adding this middleware. So we are saying that allow all origins because this is this asterisk. Allow credentials, like allow to give the credentials and so on. Methods is like there can be different HTTPS methods like get, post, and so on. So allow all that. And allow headers is like we pass this API key and the the type of input and output, and basically the API key and the header. So we are allowing that. So this is kind of a standard code that we have, and the main purpose here is just to make sure that if the front end is backend is connected to a front end that's on different domain, it should allow this. So that's the purpose over here. So the next thing that we are going to do is kind of define how the input of this API should be and how the output is going to be. So here I'll say input request model. So we can say class uh, input request. So the naming convention can be like we are having two words, one is input and the other one is request. You can put like those first starting letters in uppercase letters, and then within this you can pass base model and say question is the input that the user is going to send, and it's going to be a string. So how we would send is we would send a JSON object, something like this, and write our question. Let's say, what is AI? So this is the question that we need to send. So this question, the value, the key value pair, the value of this dictionary or the JSON should be a string, and the key should be this exact same thing that we have mentioned here, question. So like this is what we are defining here. So we are saying that it should be a JSON object that should have question as the input, and the output, the value should be like in a string format. So if you're using, let's say, you're sending the age of a person, so we say that the key should be age, and it should be, let's say, an integer value. So we define the parameter that we are going to send in the request, and also like what's the data type is going to be. So those are the two things. So question, which should be in string. Similarly, we can define the output structure as well. So let's say we call that as response body model. So here we can say class, and let's call this output response, or we can simply call this question request and answer response. That makes like more sense. Let's call this question request, and this should be, let's say, answer response. So your question is coming in request, and we are responding with the answer. So answer response. So base model is something that we have imported from Pydantic. So that's what we are using here. And then here we are going to send the output as answer is would be the key, and the value would be a data type. The data type would be string. So this is how we can define like the input and output. So now we are going to send, or sorry, create a post API. So there are two APIs. One is like get and post. Like in get, you just like pass some values in the URL itself, and you get this. And in post, we often send a body, like a JSON or some data, and we get a response back. Again, you get a response in get as well. Like post is more about posting some data to the API and getting a valid response from it. So this is post endpoint. You can say at app.post, say /ask, and then we can say response model is going to be your answer response, and then we say define, create a function, and say answer user question. So we can say answer question is a function that we are creating, and we say request would be question request. Okay, so what we are doing is app.post, we are creating a post endpoint. So this app basically comes from the fast API instance that we have created. To this app instance, we are adding the middleware, the CORS middleware, and then to this app itself, we are creating a post endpoint, and then we are creating a function that's going to call this post endpoint, and it would be called in this URL. The URL would end with ask, and then you can access it. It's okay if you don't get few of these things. So once we complete it, like it would make more sense. So don't worry about that. It's like we are creating a API endpoint, a URL endpoint called as ask. So that's going to take this question request, question as input, and then the response model. The response is going to be answer response. So that would be the idea here. And then from this response, right, so from the body that the user is sending, like when this API is called, the let's say if the front end would send you a question in the request, and now we have to extract this question from this request. So for that, you can say question is equal to request dot question. So this request is sent by, let's say, the front end, or from source. It can be coming from the postman, which we use to test our API, from anywhere, right? So let's say our API is called, and this request contains, it should contain a key called as question, and we are extracting that by saying request.question and then storing it in a variable called as question. This can be anything. You can name this anything. This is just a variable. You can call this query question or anything, just to be just to write the words clearly. I'm putting this as question. And answer, we can say that something like here is a generic answer. So no matter what's the question is being sent, we are going to send it with this particular string. Here is a generic answer. So later we would convert it in such a way that the LLM is answering that. So that's the idea. But for now, we are hard coding this. We are saying that no matter what's the question, just send it for now, as this is only a skeleton or the template that we are trying to build here. So we just send this answer now. And then you can return it as kind of a dictionary, and this is going to go as a JSON object. So say answer would be this answer that we have created. So answer is the key, and this answer is coming from here. And if you see, this contains a key called as answer. So this is going to be a string. This is what we have kind of mentioned in this answer response. Okay, so and we have mentioned in this response model as well. So that's how we have to build this post endpoint, and later we have to run this application. So for that, we say if name is equal to main, ubcon dot run mention this command. So main dot app. So that means like main is the name of the file, app is like the variable that we have used to instantiate the fast API thing, and then say host. So host would be the local host. Local host means like my local computer 127.0.0.1, and port we can also mention. So the usually we run the APIs in the port 8000, and say reload is equal to true. So that means when the code changes, reload the application. This is it. So let's try to understand what happens. Is this if main is like only runs if you do, you know, python main.py. So this python main.py is the command you can run in your terminal to start this application, or you can simply run main.py. So even this run main.py, it just like runs this command. So when this runs, then only start the application. Rather, if this file main.py is imported, right? Let's say we are importing it from a different file, something like from main.py import answer question. In that case, it should not start the application. So this should only run when we run this script separately from using this run, or from the terminal. If we say python main.py, that's when it should run. So the reason is we often create these several files and functions separately, modules separately, and we import it, but it doesn't have to run when we import it, right? So let's say that if you have this, we are importing, let's say, fast API, it doesn't have to run the entire script when we import it. Rather, it should run only when it's required. It's kind of like that. So this code, this UV the fast API thing should only run when we run this script separately, like then only it should run. So that's the idea of this. So this is the API that we have created, and now we can test this. So all you have to do is just like click on this run, and here you would see like where the fast API thing is running. So you're seeing this logs, right? So we'll watch for changes and all those stuff. So if we make any changes, it's going to reload the application, because we have mentioned reload is equal to true. And this is the local host. 127.0.1 is the local host, and 8000 is the port. So port is nothing but in your machine several services run. Let's say your API is running on 8000. If you are hosting your Olama model, Olama runs in a specific port. Port is nothing but a number where a particular service is going to run. So in this 8000, how fast API is going to run. Let's say on Flask we are running it on 5000. So it's a number using which you can access that particular service. It's kind of like an identifier that's used to access a specific service. So I can go to this particular URL, which is 127.0.0.1 colon 8000. So this is where our API runs. So here you're seeing this detail not found, but in order to test this APIs towards the end, you can say slash docs. So again, fast API, the other advantage of fast API is that it automatically create what we call as a swagger docs, where it kind of tells you like what's the input you have to send, what's the output structure is going to be. So all these are like kind of captured here and so on. So it's easy to test and make sure that the API is working. So to test it, what you have to do is click on this drop down and click on try it out. And here you can paste your question. So let's say I'm asking a question like, what is machine learning? And then execute it. and it would say this is the URL, request URL. So this is the URL you should use to access this particular input, and it says like the answer here is a generic answer. So this is the answer that we have hard coded for like any question. So it's going to return that. But the important thing is you see this HTTP 127.0.0, the local host and the port. So this local host, right, 127.0.0. So this is coming from this host that we have mentioned. Port is also 8000 that we have said. So you can give any port, so that's okay. And slash ask is nothing but the ask path, the path that we have mentioned here. So this is the endpoint. So the thing is, you can create API and you can have any number of endpoints. So each endpoint would have something called as ask. Let's say now you are creating a separate endpoint that's going to take image as input and explain the user what that image represents. You can create like separate endpoint and you can have a path like slash image or something. So it's just to identify like the different endpoints that we have and just like kind of access it later in your docs or how you're going to call it. This is the exact URL, API or the endpoint URL that we are going to use from our Streamlit application to connect with our backend. So how this entire thing would play out finally is, right, this is the part, this is what we call as a backend, and we are connecting it with the fast API endpoints. So we would write separate functions and services where it would once the user is sending a question, we would kind of, let's say, send it to the LLM, get a response and give it back. In our case, we would have multiple endpoints. So work of one endpoint would be to submit the document. So let's say the college student is uploading saying that this is from first semester computer programming, or let's say C programming, and this is my book. They would send it to one particular endpoint, and then we would receive that. We would have written the script to process the document. We would build a vector DB, and then we would have another endpoint, something like this, where they can send the question, and once they send the question, we look for the relevant content in the vector database, and then we would generate the response by sending it to the LLM, just have that entire rack pipeline and send it back. So this is how it's going to play out. So this is like the base code for our fast API endpoints. Again, this is not in a standard way yet, but as we move through, we would properly structure this with folders and how you can have it in a standard way and so on. So there is a list of to do for this particular case. Maybe towards the end I'll mention that, but this is the structure. So you have a API to which you're going to send a request and get a response. So your request is going to have a question and the response will have an answer. So that is the whole idea. So I'll stop this for now, and now let's kind of, or we can just keep it running so that we can access it from the Streamlit itself. So now I have this PyCharm thing, and as you can see, you see this green dot over here, right, in this run symbol. So that basically says that a particular script is running, and you can see like which script is running over here. You can just like minimize this by clicking it, and you can just open it again by again clicking it. So it says that it's running on HTTP localhost 8000, and this is how you can access it from the Streamlit environment. So that is the first step. So now let's see how we can create a simple Streamlit app where the user can type a question, and we send that question to this particular endpoint, to this ask endpoint, and display this answer that we get in return on the Streamlit page. So that would be the next step. So any questions, any doubts so far? Uh, okay, great. So let's move to the next section. I'll keep it as such as it is. Once we are done with this session, right towards the end, we can push this code to the GitHub. Then you can just pull it and you can work on it as well. So I'll click on this drop down and I can see the AI POC study path front end. So the front end is where we are going to build our Streamlit. You shouldn't give this window because it's going to stop this current application that's running. Instead, we have to give new window. So now you're going to have two PyCharm windows. One is for the backend and the other one is for the front end. Okay. So as you can see, it is kind of in the dev branch, as we know, like that's where we are going to work. So the next part is like, again, just what we have done. We have created like a simple fast API code. Now we have to do a similar thing, but again, a simple Streamlit user interface is what we are going to work on now. So let's see how we can do that. Okay. Let me create a new file just like the one that we have created. We can close this readme and all those things. So right click here. Again, we would have proper structures of the repositories and so on. But for now, let's just keep things simple. So as we move forward, we can like make this more standard and everything. So I'm going to say add file to Git. And first thing is we have this requirements.txt streamlit, right? And in Python, we have a library that we have to use in order to call any APIs and get a response and, uh, basically how you can call this API. So we have used this Swagger to test it out, right? So similarly, in Python, we have a way to test it out. So that's what we are going to do. And the library responsible for that is requests.pypi. So it's request with the, yes, this is the library. So the version is 2.32.3. So this is 2.32.3. Okay. So this is like the latest versions. I'm going to mention that request is equal to this. Put double equal to and open your terminal. So my virtual environment is activated. You can say this is the same command pip install -r requirements.txt. So that's Streamlit is already installed. So we installed it yesterday. And then we have the request library that's also installed as well. So I'll clear this and open my main.py file. And now I'm going to say import Streamlit as st and import requests. So these are the two things. So now I'm going to create the page icon, page title and everything. So towards the end, like you will see like how this app looks like. So I'll say st.set page config, open your parentheses, and we have to give a title to the page. So I'll say page title is equal to, let's call this study pal, the name of the application that we are building. So we can call that, and we can also have a page icon. So let's have kind of a robot emoji. And this is not mandatory, but it kind of looks good in the front end, like in the tab. Let's see how we can do that. So you're seeing this small box over here. You're seeing this GitHub icon, right? So that's what we are trying to create here. Let me close this, and for getting this emoji, I usually use this emoji DB where you can just like search for emoji and you can find something. You can also give a icon file there, and Streamlit can use that as well. So I'm going to say give me a robot image, robot emoji. Let's say that you can just like click here to copy this. Again, these are like small stuff. It's not like mandatory or something, but it just like makes it look a bit good. So I'm going to paste that over here. Again, you can just give this in a icon file or something, so that's okay as well. And then we can say page layout is equal to centered. So when you put it center, like all the content is going to be in the center of the web page. So you will see this once we build it. So there is another option called as white, so you can also try that as well. And then you're going to create a title calling that st.title, and the title is going to be you can just like copy the same emoji, put it over here, and let's call this study pal application. And yeah, so we can just like also try to run this and see like how the application looks like. So again, we still have to call this request to call the APIs and so on. But to run this, you can open the terminal. So now we are in this directory called as EA PoC1 study pal frontend, which is this, and this directory is the one that contains main.py. I think you can also rename this to app.py because that's like the usual way Streamlit kind of suggests to you can name the Streamlit apps. And to run this, make sure that in your directory you have the app.py file and run Streamlit. Again, Streamlit library should be installed. So we have installed that already by having that in our requirements file. And you can say Streamlit run app.py. Again, it's not like you have to mention this dot slash, so it automatically comes in Windows, but it's okay like if you're not mentioning that as well. You can simply just say streamlit run app.py, and this is it automatically opens it in the browser, so you can see that it's running on localhost. Localhost is nothing but the same thing. So we in Swagger we have this 127.00 Swagger docs, right? So it's like the same thing. So 127 is what we call as localhost. You can see this fast API, we asked it to run on 8000. So this Streamlit app runs on, I'm sorry, close this and open it over here. So it's like localhost. As you can see, Jupyter Notebook runs on the port 8888. We have 4 8s, and Streamlit runs on 8501. So it's not like it's the only port it can run. You can also customize this to run on a different port, so that's okay as well. But by default, it runs on 8501. So here you see this small emoji and the name study pal, right? So this is what is coming from this SID page config and the layout, right? So as you can see, everything is kind of focused on the center. If you put a wide layout, so you would kind of see this, line in a very wider way and so on. So that's the thing there. So now we can work on integrating the current API that we have. So the user can just have a text box here where they can type in some question and we call this API in return and we just like send a response. So that's what we are going to build in this front end. Let's see how we can do that. Here I'm going to give the API URL. So API URL is like make sure this is running. So if this is not running yet, it's going to give you an error. So copy this URL, paste it over here in the front end part and put a slash, say ask, because we know that that's what we have to use in order to access this particular endpoint, the question answering endpoint. So if I open this, we have this post API called as ask. When you try it out, we can ask a question, right? So what is AI? And you can see like request URL should be HTTP, the localhost URL 8000 ask. So this is the URL that we have to use because 8000 port can have any number of endpoints, but we have to specifically say like what endpoint we are accessing. So we are trying to access the ask endpoint. So we are saying that the API URL is going to be 127, all these numbers, 8000 is the port and ask. And then let's say we get the user input. So get user input is saying question, let's call this as question as well, is equal to st dot text box. So it should be st dot text input, and we can say something like your question. This is the label part. Label is equal to ask your question or something like this. And then for placeholder, these are like optional parameters. It's okay if you don't have this as well. You can say something like example, what is Yemen or something like this. So we have made a change, but the Streamlit app is still running. So if you open the port where Streamlit is running, this thing, it says source file change. Source file is nothing but this app.py file that we are working on. In order to reflect the changes, you can just like refresh this page. So now it says ask your question. So this is the label that we have added over here. And you see this placeholder, right? So this placeholder is what you are seeing in kind of grayed out over here. I'll just zoom this a bit and we put it on dark mode. So to display this application on dark mode, you can just go to this options, three dots, go to settings and change this app theme to dark. So that would just like make everything look black and so on. So you have your label and your placeholder. So now when the user kind of like types in something, so this is a text box, so I can just like ask something like what is this document about, and now we have to create a button. Once that button is clicked, we have to send this question to the API and get the response. So that's the last piece that we have to work. So say let's see how we can do that. So here I can say button to trigger the API, the post API that we have created. So I can say if st dot button, and we can just give a name for this button. Let's call this get answered button. And when this is clicked, so this if condition, right, by default it would be kind of like false or none, but once the button is clicked, this value changes to true. That means this if block is going to run only when this button is clicked. So that's the condition. So the condition for this if condition, the if statement is to check if the button is kind of clicked. So that's the thing. And here I can say if let's say once the question has been sent, we can say that response is equal to, let me just add another space so that it looks okay. Response is equal to request.post, because this is a post endpoint. If it's a get endpoint, you would mention request.get. And within this, you have to pass your API URL. I think the parameter is URL. So I'll come to the next line to create that indentation and say URL is equal to API URL. And then we have to send this JSON. So JSON is equal to question, comma question, the user question. Maybe we can call this user question to be more precise. Okay. So what this question is, this is nothing but the request model that we have defined. So here, if you remember, we have a question request model. That means like the JSON payload should contain a key called as question, and the value should be in the form of string. This is a text input, right, in Streamlit. So this is always going to give you a string, and we are putting that in a JSON object or kind of a dictionary with the key values question, because we have already defined that this is how the input to the request should be. And then you would get a response. You have to convert this response. So this response would often come in a response body, and you have to convert this back to a dictionary. To do that, you can say answer, the final answer is equal to response. Yeah, we can maybe do that in this two steps. Let's call this a result, which contains like the final response body. So I can say response.json. So this is going to convert into a proper JSON, and this JSON basically contains this thing, return answer. So it has an answer key, and it has this hard coded answer called as answer in the string format. So what you can do is convert this to the dictionary and access only the answer part. So that's what we are going to do here. So we are creating this to a JSON, and finally you can extract that answer by saying answer is equal to result is result of answer. And finally you can say st.success, which is going to put a green box, and within that green box we can say something like answer. So how this entire thing works is the user goes to the Streamlit tab, types in some question, and click on the button called as get answer. So this is going to, once the button is clicked, it's going to trigger this API, the request API, the post API is going to send this payload with the question that the user is sent, and it's going to get the answer from the API back. So that's how this entire thing works. And now if you see this, right, so it says request 200 okay. So 200 okay, 200 response code is like when everything works successfully. If there are any errors, the response code changes and so on. We will come back to this later. Just remember that 200 means like everything is successful. So now you see like three places where it says 200 okay, because those are the ones that we have tested with the docs and so on. And then we have within the docs we have tested the ask API, right? So that's what it says. So once we run the Streamlit app, once the API is triggered, you would see like another value here which represents the call that's made from Streamlit. So now I'll come back to this. We have changed the Streamlit code. Now I can open my Streamlit app. So this says the source file change. You can either click this rerun, or you can refresh this. Now it says ask your question. We have this button that we have, and when you hover over this, it kind of changes the color to red. So now I'll ask the question like, what is let's say Streamlit. Again, we know that it's always going to give the same output, but the main thing that we are focusing here is like, if everything is working okay, if we are able to call the API properly from the Streamlit apps. That's what we are looking at. So now I'll click on this get answer. It says object of type set is not JSON serializable. So that means like we got some error from the request that we sent. So let's maybe try to validate like what's happening. So here you don't see anything. That means the request has not been sent properly. So let's come back to this terminal and see like what's going wrong. So we have API URL, that is HTTP 127 ask and all that. Okay, so this looks okay. And then so result we have response.json. So this is also looking okay. Response is request.post. We are sending this API URL and the JSON. script runner line 20. So line 20 is okay. So it's we have an issue in sending the request itself. Hmm. Okay. So this is not JSON serializable. I think it's request. It's expecting it in a. Oh, okay. This is the issue. So we missed a colon. So instead of colon, we put a comma. So that's why it's not able to process this as a JSON object. Okay. So now you can maybe kill this process. To kill this, come to your terminal, press Ctrl plus C. So that's going to stop the application, clear all the history, and again run the streamlit run app.py. And this would again open this. And here I can say same question. Let's say what is streamlit. Click on get answer. Now it says like here is a generic answer. So this green bar is coming from the success st dot success, and the response, the answer text is coming from the API. So if you look at this API, so previously we had like 3 rows and now we are like the 4th row, right? So again, if you call this with let's say another time, so you would see like another row. You didn't see anything change because the answer remained the same. So if you want to test this again, you can just refresh this and say like what is ML. So we get the answer. So this is how this entire thing works, and you can see like the output that has been called from here. We can add more logs, like when you get a question, you kind of print like what that exact question is from the backend, so that we can monitor it. We can monitor like if something is going wrong and all those things. So we can like add like all those logs and stuff. Again, there are like so much things to do here, but this is that uh, initial part, initial skeleton for our front end and back end, and this is how things are going to be. So we would restructure the folders and everything to make it in a more standardized way, but this is the whole idea. So you have something running in your backend. Uh, this is the part where we would access the LLM. Either if it's a Grok KPI that we are going to use or it's a Volama model we are going to use, all those code comes here. So all those code stays here, and your front end code stays in your Streamlit app. So later, when let's say a different user interface, a different tool is used for building the user interface, you just need to like alter a few things in the back end. Like you can just like ignore like the front end part. We don't need that anymore because now we are using a different front end tool. So this is the idea where we kind of have a clear separation between the front end and back end, and then we can just like keep working on the things individually. So this is like the whole idea. And the other thing that we have to do here again, there are several things, but the key things that we will probably do like a bit later, like are these things. So I'll add a file called as to-do.txt, basically a file that tracks like what are all the things that we still need to do. I'll mention this. So we need to add logs so that at each step we know like what's happening. So we can check that whether like the request has received to the backend, and check like whether the error is coming from the backend or the error is coming from the Streamlit app front end. So we like could add separate log files for the front end and back end. So that's one task that we have to do. And the other thing is add API keys to access the backend endpoints. So here, what it means is like when you're using OpenAI thing, you have a API key. For Grok, you have API key, right? So the purpose is only the front end who or the person who is developing the front end, if they have access to the keys that they're creating, then only they can access this API. Otherwise, anyone can use this, right? So it's like we give the access keys, the API keys to only people we want, and they can use this. So we have to add that layer of security to our API. For now, this backend doesn't have any API keys, but that's one thing that we need to add. And the other part is like how we are going to handle exceptions, like how we can, you know, gracefully handle the exception. If there are any errors, we shouldn't throw a red error message to the user who doesn't understand technical stuff. So we shouldn't do this. So how we are going to handle this, how we are going to like kind of say that, if something goes wrong, how we are going to send that to the user. So we have to handle this exception in all the parts of the code. And finally, we have to structure this, the code base in a more standard way. So these are some of the stuff, and again, as we have more stuff to do, we will keep doing this, but this is like kind of the basic framework that we are going to work on. So you have a front end with fast API, and you have a sorry, front end, we have Streamlit, on the back end we have like fast API, and then we can just like kind of add more features to this, like upload feature, ask answer, question answer features, and so on. So we would like do all these things like step by step, and finally like we would have this entire application that we can just, let's say, ask people to use. So this is like the entire idea. So now once all these are done, so once you're done for the day, what you do is like you kind of like push the code to um, you know to GitHub repository. To do that, what you can do is I'll stop this application. There are two ways to do this. You can clearly see the files that we have added. So the green color one, blue color one, the green color one. So you can just like select all these things, right click here, go to Git and commit files. That's one way to do this, or you can also do this from the terminal. So open your terminal, say git add space dot git add and dot. So this is going to add all the files, the changes wherever we have made the changes. So it's going to add all this to the git. And then if you want to make sure that everything looks okay, say git status. If you have some other files which shouldn't change, again do a git reset and you can just like change those things. So here we have created a new file called as main.py, modified a file because requirements.txt was already present, and we have created another file called as todo.txt. And now I can commit this. Commit is basically like committing this change, and you give a message saying that base uh, this is backend, right? So base backend API code, and say git push origin. So we are working on dev environment. So dev branch, as you can see. You can also see it when we call the status as well. So it would mention the origin dev thing. So you can say git push origin dev. Spelling is wrong here. And this would push the changes to GitHub, right? So once you open the backend thing, right? So it says there was recent pushes. If you refresh this, main branch doesn't have changed because we didn't work on it. So we worked on dev branch. So later, once we are done with the feature, we would create a pull request and merge it to main. So now you see this main.py file requirements thing, and it has the message called as base backend API code that we have worked on, the commit that we have just now done. So similarly, we have to do this for the front end code that we have worked on. So this is already running in the backend. You can either stop this or do this in a different terminal. I'll just stop this, press Ctrl plus C, clear everything, and again just do this git add, and then the git status. Again, if you just want to check this, but I think everything looks okay, so I'll say that base println code with Streamlit. Just a message to track like what is the exact thing that we did. Run this and say git push origin dev. So this is okay. Git push origins. There is a typo. This is how you can make sure that the work is getting saved properly. So even something crashes, let's say like you have mistakenly like deleted a file and so on, so that's not lost because that's now in a common storage in our GitHub repositories. So if you open your front-end code now, and you can see like all the changes that we have done. Okay, so you have everything in there. So this is how this entire thing works, and you can go to this commit message to see like all the changes that we have done, which is like we have created a app.py and we have modified the requirements.txt and so on. So this is how you can like save your work at the end of a session or the end of like your work day or something. The standard way to do this. So these are the things that I wanted to discuss today. So maybe tomorrow what we can do is like we still have like few things like how you can add a config file, how you can add a .env file. The purpose of this, maybe what we can do tomorrow is create all those .env file, config files, discuss about this, and in this API, right, instead of just giving some random responses, let's connect either Olama model or Grok model, and we can just send a proper response for now. So that's something that we can do. And then the next thing is like, yeah, after once that's done in the session after that day, we can just like uh, create the wireframe where we design the user interface properly with some pages. We don't have to create the wireframe is nothing but just like a design of how the user interface is going to be. First we can work on the upload page part. So once everything is done, then we can move to the chat page, and then to the admin page and so on. So it's like the reason is like to make sure that we get quite some good hands-on in our session and not like just focus on non hands-on part, non-coding part. So that's why I'm planning this way. But this is something that we can do. So please practice this codes that we have done. So you can just like go to the, I've asked you to fork the repository. So you would see an option called as sync fork. So you can do that so that your repository is like updated with whatever like I've created. So make sure that you have a dev branch, and then like you can sync the fork. You would see a button somewhere here in your repository that you have forked, or you can just like fetch the changes from PyCharm. So that again I mentioned in today's video that I dropped, so you can check that as well. But this is the thing. So yeah, these are the things that I wanted to discuss today. Is there any other questions that you want to ask? We can maybe discuss it for like the next 5 minutes. If not, you can drop and we can wrap up the session. Shadab Ali, what are you trying to do? So we are trying to build an application. It's more of a RAG chatbot to put it simply, but we are trying to make it as standard as possible in a more of like production ready thing. You can watch the previous streams and stuff to get an overall idea of like what the application is about, and so on. Today's session is like kind of setting up that base code on top of which we are going to do this application. So this is what we are trying to do. Uh, any other questions? Okay, in that case, we can. I'm a big fan of yours, bro. Thanks a lot, Shadab Ali. So I think we can wrap the sessions for today. Good night, everyone. See you tomorrow. Bye.